Hi, I'm James McGuire, and on today's eSpeaks, we're talking about quantum computing, what it can mean for your business, how it works with artificial intelligence, and most of all, what is it? How is quantum computing going to change technology in the years ahead? To discuss that, I'm joined by Ilyas Khan, Director and Chief Executive Officer of Cambridge Quantum. Ilyas, thank you for being with us today.
Hi, thank you. Good morning or good afternoon, I should say.
Well, you of course are in the UK. It's 10 a.m. here in the San Francisco Bay Area. I assume it's probably what 6 p.m. there in the UK.
Correct.
Yeah, I think it's amazing that this is not new technology, but I think it's amazing we're talking to each other over these interactive television sets, so to speak, all the way across the other side of the globe. I almost feel like maybe the future is here, Ilyas. Do we feel the future is here? Or are we still waiting for it?
Yeah, well, my bones told me the future was here yesterday, but yeah, no, I agree with you. It's pretty amazing. And I think the quality of these things has increased markedly in the
Right.
last 4 years, and that really makes a difference.
So I've got to ask sort of the very basic 101 question about quantum computing. I kind of hesitate to do so because, I interview all sorts of people and I don't ask, what is cloud computing? What is artificial intelligence? Because mostly people know, but here I am talking to you about quantum computing. I'm afraid I'm going to have to ask, even here in the year 2021, what is quantum computing and why is it so hard to explain?
Well, first of all, I think that in a few years' time we will take it for granted.
Hmm. Hmm.
None of us really, if you push anybody and said, how does your mobile phone work or how does your brand new car work? We don't really know, but we use them.
Right,
And we're
right.
very happy to use them. So I think that migration will happen. Yeah, look, I think that there is this mystique about the word quantum, and the mystique is there for very good reasons.
Hmm.
Quantum computing, which is really based on quantum mechanics. Quantum mechanics is a science that's just over 100 years old in terms of the way that it was discovered. And
Hmm.
it's experimentally proven, perhaps the most proven physical law. So we know all about it and have known for a very long time as humankind. We
Hmm.
still don't know why it works. We know the what, but not the why.
Hmm.
So luckily for us, quantum computing is focused on the what, which is very easily explainable. There's
Okay,
really
good.
no
I'm
reason.
relieved to hear that it's easily explainable.
Yeah. There's no reason for us to worry about quantum computing. I think when people start trying to explain quantum mechanics, the underlying science and the why it works, of course, that is a discovery yet to be made to the point where it's explainable in easy to understand language. Look, a quantum computer was first conceived of by 2 or 3 scientists roughly at the same time. And if you think of the sweep of history, this happens a lot. Leibniz and Newton kind of came up with calculus at the same time. Then a
Right.
whole cluster of people came up with ideas around relativity at the same time. Obviously, Einstein was the one who perfected it. So a quantum computer was conceived of by somebody, let's pick on Feynman, Richard Feynman, the very great American scientist,
Mhm.
around the end of the 70s, the early 80s. A couple of other scientists like Yuri Manin and David Deutsch were also in the mix. And it is where a individual unit of information is represented by a physical thing, and that
Hmm.
physical thing is a atom or a subatomic particle. So if you
Aha.
think of, just to finish that idea off, if you think of this, here's my iPhone. So this has got billions of transistors in it. Individual units of information are represented by transistors that are on or off.
Right.
And over the course of the last 40 or 50 years, transistors have got smaller and smaller and smaller.
Sure.
So a quantum computer is a computer where the individual unit of information, the bit, is no longer a transistor, but is an atom or a subatomic particle. And the reason that that matters is that the laws at that level of infinitesimal material, the laws of nature, are different from the laws governing the classical world, the one in which
Right.
you and I live.
Well, so all right, that's fascinating, and that makes perfect sense to me. Because I think about the classical computer is representing information with ones and zeros. Everything is divided into this binary world of ones and zeros. You're saying in the quantum world, there is actually a physical atom that corresponds to the information.
You've nailed it.
Wow. I actually
Yeah,
understand quantum computing. We might as well
Dr.
quit right
McGuire.
now. I think I know what we're talking about. Okay,
Yeah,
please go
yeah,
ahead.
yeah. Dr. McGuire, I mean, you've got it. In fact, many people forget this, but I think it's worth reminding. Computers are physical things, right? They
Right,
need to be
right.
made. And when we say zeros and ones, when you and I say 0 and 1, all we're doing is we're abstracting away so that you and I can understand something that actually isn't a 0 or a 1. It's an electric current that is either
Right.
passing or not passing. So you go all the way back to Turing and other people, Church and Alonzo Church, and also people like Shannon and many others in
Sure.
the 30s, 40s, and 50s. And this progression in classical computers, when I say classical, I mean existing computers, is
Right.
all about efficiently capturing on off. Why? Because first order predicate logic can be represented. So this conversation you and I are having is lots of yeses and nos, ands and ors, negation, right? So all these things make up the world around us.
Mm-hmm.
But what we discovered earlier in this interview, I said about 100 years ago, people discovered
Right.
quantum mechanics. They discovered that the world at the atomic level doesn't obey the laws, or in fact, the laws are different.
Really?
When
Okay.
you start,
Well, of course they would be.
well, it's the law of nature. That is nature. Nature, it is ubiquitous. Everything in the universe that we are aware of is made up of these atoms and subatomic particles.
Of course.
Literally everything.
Right. Right. Well, then what is the advantage of quantum computing over traditional classic computing? Why is it better, faster, stronger than the old way, so to speak?
So I think that just before I answer that question, I think
Please.
as with any technology, medical technology, communications technology, transport technology,
Mhm.
the why is it better becomes apparent when you look back, right? So
Okay.
if, when the first telegraph came, and you remember the famous story about the Bell Labs guy saying, well, you know, I think we need one of these, or you know, imagine in Chicago or Winnipeg, you know, some carter making wheels for a cart and being told about the railway, and he was like, why are you bothering me with this? So
Right. Right.
we can guess, but really things proliferate when humankind gets their hands on the technology. As
Mhm.
best we can tell and as best we can articulate, this is an industrial revolution, the likes of which
Right.
has never happened.
Profound. Right now, as we sit here and speak at this very moment, we're in the middle of a deeply profound revolution in
Yeah, we are
technology.
living
Yes.
through stuff that people write about for, you know, for the next, in the next 2, 3, 4, 500 years, people will look back and say, at the beginning of the 21st century, quantum computers came. I mean, this is like the spinning jenny moment for the industrial revolution. So the
Hmm.
late 18th century,
Mhm.
you know, we were mechanizing how cloth was made. And
Hmm.
so people could do things using machines where it would take lots of people or none at all because we weren't strong enough or fast enough. That's when machines came in, right? And steam
Mhm.
engines and then cars, etc.
Right.
So to answer now your question, a quantum computer operates in a way that in certain areas extends the boundaries of what can and cannot be done. So certain things that could not be done by a computer will now be able to be done.
Really?
At
Okay.
the moment, at the moment, people are not sure. And so when we're not sure, we become cautious. We're
Mhm.
not sure whether everything that you can do on a classical computer could be done better on a quantum.
Hmm.
So the informed consensus will be no, 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 no. Quantum computers will not replace classical. So,
Ah.
and
Okay.
I think that's a good place to be. Remain grounded, but then look at the areas where quantum will profoundly change all of our lives.
Mhm.
And in those areas, what is it that a quantum computer finds hard to do? Well, this conversation, classical computer, this conversation you and I are having, no computer can have. In fact, you
Right.
could aggregate every single computer in the world, you could plug them all together and get a mega computer the size of the
Mhm.
planet it still
Right.
wouldn't be able to do what you and I are doing.
It's true.
Human beings can speak. We understand nuance. We can have long conversations. The best we can do at the moment is say, "Hey Alexa, play me a Beatles song," right, or something, right?
Right. Right.
And that's not understanding. So that's one area where quantum native applications will come through, and then the other one is in material discovery, where
Wait, let
when
me
we
understand. Let me make sure I understand your first point. You talked about all the computers in the world could not have our conversation. You're saying that paradigm is turned on its head if one of them is a quantum computer. I want to make sure I understood what you just said.
yeah, so quantum computers can do things that classical computers cannot.
Could they mimic this conversation you're saying? Possibly.
I'm not saying mimic, I could say
Okay.
have.
You
I'm,
actually have it.
yeah,
Okay.
yeah, I'm going one step further. Yeah, yeah, yeah,
All
yeah.
right.
So at some point, so we are at the infancy of quantum computing. And so you've asked me to look forward, and whether
Right.
it's a year away or 3 years away or 5 years or 10 years, it's
Mhm.
in that time frame. We're not talking 50 years from now.
Right.
And
Right.
in this short time frame, I mean, shorter than, let's say, 2010 was, or the London Olympics was 2012. So that's 9 years, right?
Sure.
So in the same sort of time frame, quantum computers will have a meaningful impact, at least in two areas. One is material discovery, to
Hmm.
allow us to heal ourselves, allow us for, let's say, carbon sequestration to become a reality, allow us, for example, to do photovoltaics better so that we can save the environment. That's one cluster of things,
Hmm.
which goes by the name quantum chemistry. And
Okay.
then the other cluster of things that has been discovered to be quantum native is language.
Hmm.
So these are two clusters of things. Now, there's a whole host of things which could and probably will have a big impact as well. We're speculating a little bit now because we don't have the firm evidence.
Right.
But this last year or two, each week, each month, that speculation becomes less of a speculation because these devices, these quantum computers, are now available. They weren't 2 or 3 years ago.
Right.
And in that category, the third category, the last category, is all the things that classical computers are doing in what you and I would call machine learning.
Right.
So optimization, all these things that go by the name neural networks, that
Yep. Yep.
I think you guys have talked about before in your programs.
Hmm.
So there are these three areas, and in each one, there is some reason or evidence, and in some cases, in the first two, proof that a quantum computer will do better. So the question then is, what are we waiting for? Why aren't we doing it today? And
Right.
the answer to that question is that we're still in the first generation of quantum computers have just arrived. So if you think about the classical age, we are probably, maybe the 1955 moment in
Oh.
compute,
Okay. Well,
right?
that primitive, that full of possibility, but also that primitive.
But also where it took 30 years to get, or 25 years to get to the personal computer, 1980, it ain't going to take 25 years from here.
Okay. Yeah.
That's what I was
Interesting.
saying. It take a few years. So some useful things, and you and I are recording this in the middle of October.
Right.
I can say with some degree of confidence that before the end of January, so let's call it in 4 months' time,
Right.
there will be a service that people can use and buy and pay for that is useful, that is being done by a quantum computer that cannot be done by a classical computer. So
Uh-huh.
some things are just around the corner. Just as in let's call it 55 and 1960, people were starting to use computers. They weren't ubiquitous, but they were beginning to be.
Sure.
We're at that stage. The first applications will come out, and I'm afraid I can't disclose what that application is.
Right.
It's to do with cybersecurity, but a quantum computer exists today that doesn't have to get better or bigger in order to generate a product or a service that will affect what you and I do. So we're actually
Hmm.
quite close.
Interesting. Okay. I want to ask you sort of two questions at once. I want to give you a chance to talk about your product line, and I I love what you said is that language, here's the first part of the question, is that you mentioned that language is quantum native. I'd love for you to explain that, but at the same time, I'm going to ask you another question. I know that Cambridge Quantum has released what it calls the world's first quantum natural language processing toolkit and library. So like what is that? And does it relate to the idea that language is quantum native? That's a very complicated and obtuse question, but I'm asking you
No,
anyways.
no. As questions go, they're both very straightforward parts.
Okay.
Nothing
All right, good.
nothing obtuse about them at all.
Good.
So Cambridge Quantum is in the process of merging with Honeywell Quantum Solutions.
Oh, okay.
Okay, so we are awaiting regulatory approval. On June the 8th, we announced a merger, and the merger was subject to the approval of regulators in the United Kingdom and in the United States.
Okay.
And we're very hopeful that approval will come through.
Mm-hmm.
That approval creates the world's largest integrated quantum computing company.
Hmm.
And we have been described by barons as the Apple of quantum computing. Now,
Wow.
that's
Okay.
yeah, it's very flattering, but it's
Very.
also but it's also very true.
Well, that Ilyas, that also makes you Steve Jobs, not to give you a God complex, but just so you know.
Well, that's right. I wish I had the hair to go with it.
You need a turtleneck, but okay, please.
Yeah, I need to roll back 30 years as well. So,
Right.
um,
Right.
but as a company, we what we do is we are an integrated provider of solutions that are quantum computing solutions. So we are a software and a solutions company, if you like. And so I won't go into everything that we do, but
Right.
we have the world's first operating system. And the product I mentioned to you is the first product that will be launched in the first quarter of next year, I hope, or perhaps earlier, which will
Okay.
be only quantum. It's the only thing that can be done by a quantum computer at the moment that
Mhm.
is not possible to be done classically, and which matters. It's not just a scientific project. Now, coming to language, this is, I'm very excited by this, and we all of us have been fascinated by language for as long as humans have been around.
Right.
Whenever Homo sapiens started to convert ugs and ugs into language.
Hmm.
So, in a very, very short sentence, a quantum computer is a computer that processes information using the laws of quantum mechanics.
Right.
In order to program that, you have to have an algorithm that is a quantum algorithm.
Hmm.
And it turns out that quantum algorithms describe exactly language processing, not
Hmm.
approximately, but exactly. This was an intuition of one of our founding scientists 10 years ago. And 3 years ago, that intuition started to be proven out when the first quantum computers became available for experimental use. And what we announced on Wednesday of this week, 2 days ago, is that we have now made available in the public domain on an open source basis a rather beautiful and slightly mysterious toolkit, which is think of it as an SDK, think of it as a
Right.
bird or something. And
Sure.
what you can do is you can go and you can type in this sentence. I'm speaking to you right now, and you're in San Francisco, and I'm in London. You could type that in, and out pops a quantum circuit, which is
Hmm.
unheard of, absolutely unheard of. If
You mean
I'd
you
have
mean
said that,
the software code for a quantum
yeah,
circuit,
no, the circuit,
the actual physical circuit?
yeah,
Huh.
the
Okay.
circuit. If
Wow.
you, well, big wow, and that therefore is the first step in allowing natural language processing using these compositional methods to become useful to humankind as quantum computers start to scale.
Uh-huh.
And is that a year, or is that 3 years, or is that 7 years? We will find out. But
Sure.
we will have the applications ready. Why is that important? That is important because within the whole suite of AI, language processing is perhaps indicative of the hardest problems. If we solve language processing, we can solve AI, which means that
Mm.
at the moment we rely on opaque, brute force methodologies, which
Hmm.
are not good. right? They're not good for
Hmm.
you, they're not good for me, they're not good for our children or our neighbors. If we can have less opaque systems where there's accountability and interpretability, that is good. And if it's cheaper on the environment, that's even better.
Mhm.
That's what we've announced on Wednesday, that it is possible to do that. It's a big wake-up call.
That's pretty amazing. Let me drill down into your comment a little bit that language is quantum native, because I'm thinking about, you said that the processing that goes on in quantum is the same as the processing that goes on in language. If I question that, it's like, I know that the processing that goes on as I speak right now is happening deep in my brain.
No, let me
I'm not
stop
even
you
sure
there.
that, no, please explain.
Yeah. Let me stop. So let's not get into philosophy.
Okay, good.
Yeah, because, well, we could. I would be fascinated, but
Right.
like I said earlier, quantum mechanics is one of the most experimentally proven areas of science,
Okay.
and there's no reason for us to wave our arms about. So, language processing, natural language processing, everything from Alexa through to Google recognizing what you're typing,
Hmm.
an algorithm, right?
Yes.
Yeah.
Yes.
So it turns out, and these are approximations, and I'll give you an example in a moment. Similarly, if you and I want to design a drug, oh no, design a material that is
Hmm.
perfect for sequestering carbon,
Okay.
why has that not been done yet? Now, the answer,
Yeah.
yeah, we've been trying to do it for 40 years.
Okay.
We've not cured cancer. Why not? We've not cured Alzheimer's. We've not cured Parkinson's. It's trial and error. Existing computational methods, we know what the theory is, we know
Hmm.
what the end product is, we know what the material should be like. So why haven't we done it? We
Hmm.
haven't done it because designing new materials at the molecular level is a quantum chemistry problem. It is
Hmm.
therefore quantum native. And the algorithms that describe that can be implemented on quantum computers.
Hmm.
And we don't have to worry about it in the sense
Okay.
that the computer does that. I won't go into the next level of detail. A language processing algorithm, which effectively takes as input words and which uses vector spaces to represent and embed meanings, can be, and has been, I should say, not can be, has now been turned into a quantum algorithm. And it turns out, and there are papers we've published on this, it's not just what we claim, we have published papers and we have proven it by publishing in open source the program. So there's no arm waving here. We're not saying we're claiming it. It has
It's
been proven.
fact.
These are quantum native. You can run them on a quantum algorithm, and the results that you get out are absolutely devastatingly and fundamentally and profoundly different from what we do when we use brute force opaque methods.
Interesting. Okay. All right. Well, with that in mind, you've certainly talked about the future of quantum. But if you drill into that idea, if you look, say, 3, 5 years ahead, maybe even 10 years, but whatever time span you wish, what do you see as some milestones for quantum
Well,
computing?
let's
Please.
say 20, yeah, let's say 2035, because I think that's nice and a round number.
Okay.
And most people listening to this will aspire to be around at that time.
We
So I
hope.
know,
Yes.
yep. So 2035, 14 years from now.
Right.
And it could happen a lot earlier, and I don't think it'll happen later, but let's so I suspect that one of the most outwardly obvious manifestations is that one of the following things will have been solved by a quantum computer:
Hmm.
cure for Alzheimer's,
Hmm.
a material for carbon sequestration,
Okay.
a material that is more effective at the photovoltaic process than anything that we have created up until now, a graphene material
Right.
that has the tensile strength and the flexibility that is capable of being mass produced for all the uses at the micro nano level that we need. One of those things will have been solved, or should we say the material created. That is one thing that will have happened.
Hmm.
right? So that's on the material. Then quantum chemistry products in the new material area will also have resolved this problem of nitrogen fixation. You know, some people talk about using some very high percentage of the world's natural gas to produce fertilizer. We
Right.
need fertilizers for the earth. And it's a very polluting process. In fact, if you listen to what IBM and Google and Microsoft say about quantum computing, they always use this example. And I think they're right. I think nitrogen fixation is likely to have been solved,
Okay.
right? So that's the fifth. So one of those five will have resolved. Then I'll add a sixth. This AI process that we talk about, which
Right.
is deeply, deeply damaging to society because it is opaque and non-accountable, is
Right.
also
And not,
very
not
expensive,
explainable.
neither explainable nor interpretable, which together means accountable, right? So if something's opaque and you don't understand what's going on, it cannot be held accountable. It's a bit like
Right.
me having some psychosis and getting this, this is a lapis lazuli ball, and throwing it at the screen. And you say, why the hell did you do that? And I'm like,
Right.
oh,
Right.
I know, right? Yeah. So that's equivalent, right? These issues, which also mean that these are the domain of very, very expensive organizations, which themselves then are not held accountable. You guys in the States have just gone through a week of this soul searching, you know, with the
With Facebook. Right. Yeah.
yeah, and I, you know, it's not just about Facebook, but just generically how AI works.
Sure. Right.
I think we will have moved on. A new generation of techniques, because of what I've explained before, could be there. I'm not saying will be. So I've given you six things now that one of which could be. I think all of them might be. And then I'll give you one last one,
Hmm.
which is that we really ourselves, all of us who live in these times,
Mm-hmm.
have a computer that we think, gee whiz, wow, because we've gone on a journey in the last 25 years, the last 30 years, the last 50 years.
Mm-hmm.
I think that in the next 14 years, the advances in technology will make the last 70 or 50 years look like a weekend.
Yes. As wild as that sounds, I think you're probably right about that.
Because of quantum, not because of anything else.
Okay.
Longevity. Think about longevity. Think
Mm-hmm.
about drug delivery, not just not just drug discovery, but delivery as well.
Hmm.
You know, we don't need to be, you know, I was reading the other day about people spending millions of dollars going into the upper atmosphere, and you know, the carbon, God, I don't even know how much that costs in carbon. Why would
Right.
we even bother and worry about things like that when there's so much richer resources at hand? You know,
Mm-hmm.
okay, maybe we can do that. You know, I don't want to be a killjoy, but
Sure.
there are far more important things that we can do with technology, you know, than go for joy rides into the near atmosphere. And I
Right.
think I'll finish with one last thing. The other thing is, by 2035, if quantum computers, if we have fault tolerant quantum computers, then I think that we also can get more out of classical compute.
Ah,
Because
okay.
yeah, we that hybridicity, that ability to use the best of both worlds, we've
Mm-hmm.
never had that. And so
Hmm.
I don't know what the innovations will be. I'm not that smart, but
Hmm.
there will be innovations in that category as well.
Hmm. Ilyas, it's been fascinating. I've learned a ton, and it's going to be really interesting to follow the sector in the years ahead. Some big things coming, I believe. Thank you very much for sharing your expertise today.
You're very, 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 very welcome. Thank you.